Hello, my name is Rupert Ecker. I'm a cell biologist by training, co-inventor of the tissue image cytometry technology, co-founder of Tissuegnostics, and the company's chief executive officer as well as chief scientific officer. It's my pleasure to give you an introduction today to our technology, which allows to address tissue complexity through AI-empowered spatial biology solutions. It's all about quantifying microscopic images. We see here a very typical and simple example of a bright field image in colon stained with a marker well known, Ki67, for proliferation. When we look at this image, the obvious question is how many cells are proliferating? In other words, how many of the blue nuclei are stained in brown? We made a survey among more than 200 scientists, and believe it or not, the answers we received range from 1 to 40%, which points to a major problem with visual evaluation, that is, that you do not get reproducible results, just more or less arbitrary estimations. With our TissueFacts platform, we provide observer-independent data, like this scatter plot, where each individual dot here represents a single cell in a tissue section. And by using negative controls to set this cutoff, we can determine on an observer-independent basis what is positive and what is negative. And the result is 15.49%. And whenever we do this analysis on Monday morning, on Wednesday noon, on Friday afternoon, in Europe, in Latin America, in Australia, it will always be the same result rather than a more or less arbitrary estimation. Based on these grounds, Tissuegnostics has been founded in April 2003. So this year we celebrate our 22nd anniversary. Our corporate headquarters are in the city of Vienna in Austria, in Europe, but we have a global structure of offices and subsidiaries on all continents, including Tissuegnostics LATAM division, which is located in Sao Paulo. I'm proud to say, as we're tracking what our clients around the world do with the instruments and software they purchase from our company, that we now have more than 3,200 reference papers published from research groups in more than 60 countries. You will find the always current list on our webpage. And Tissuegnostics is an ISO certified manufacturer of medical devices. But we are not just a software company, but we adhere to a number of quality management standards and normative references, which are listed here. I'm not going into detail, but I would just like you to be aware that this is our regulatory framework on which we operate. We have defined our internal quality policy, to which all members of Tissuegnostics, including myself as CEO, are bound. And our vision is nothing less than shaping the future of personalized medicine. To reach this goal, we also collaborate closely with academic partners. And over the past 22 years, there have been dozens of collaborative research projects. I would just like to mention the 7 most prestigious ones, which are EU-funded Marie Skłodowska-Curie innovative training and doctoral training networks. And they are listed here that dealt with digital pathology as such, with University of Nottingham in UK, the cell migration studies with Technical University of Aachen in Germany, Alcatraz, the network on translational oncology dealing with the anaplastic lymphoma kinase, with University of Cambridge in UK, the calcium sensing receptor network with Medical University Vienna, Helical, the training network on big data analysis by machine learning for clinical benefit with Trinity College in Dublin, multi-drug resistance at the Erasmus Medical Center in Rotterdam, and Eradicate with Medical University of Vienna, the training network on nuclear receptors. And As a matter of fact, as I'm recording this video, I'm in Santiago de Compostela in Spain, joining the midterm evaluation of the Eradicate project. The product platforms of Tissuegnostics consist of two main streams. They are called Tissuefax and Colubris. Tissuefax is the open imaging platform based on microscopes from Carl Zeiss. We are OEM, Original Equipment Manufacturing Partner of Zeiss Germany. And the instruments are available in a variety of configurations for scanning bright fields or transmission microscopy samples, as well as fluorescent. We have a system for multispectral imaging with a liquid crystal tunable filter, a spinning disc confocal for whole slide confocal imaging, a system with a slide loader which can be combined with confocal as well as multispectral for high throughput scanning of up to 120 slides, and an inverted system where you can also work with microwell plates and cell cultures to live cell imaging or time kinetic experiments, at least when you combine it with a culture chamber. The second product line is a boxed type of tissue cytometer named Colubris. It is server-client architecture. It runs under Linux, but you can access it through Windows, Mac OS, or even from tablet. It is bursting with AI algorithms that cover the entire workflow from sample identification up to statistical analysis of the results. It also supports 8 slides for bright field and fluorescence scanning. All types of samples can be analyzed, from paraffin, embedded tissue, cryo-cut sections, biopsies, TMAs, tissue microarrays, and so on. Whatever configuration you choose, the immediate output of any scanning process will be the virtual slide. We see here an example of a tonsil with 7-color immunofluorescence with the currently very popular opal stain. And when we zoom in, we see more and more detailed the beauty of the tissue architecture, but we also see that it gets confusing when you have many markers stained in parallel. You need computer-assisted technologies for analysis. And this is what Tissuegnostics is offering. Our flagship is StrataQuest, the spatial biology software, which comes with machine learning and deep learning solutions to identify nuclei, tissue structures, tumor areas, glands, prostate, for example, glomeruli in kidney, and so on. What our clients around the world appreciate most is the ability that you can track individual cells between the image, the virtual slide, data space. So when you click on an image, that cell starts blinking in the scattergram, so you know exactly where this cell is located. Following our motto, from image to data, we consider this a step forward and thus call it the forward connection. It also works the other way around, from data space back to the image. You can make a gate, which is a selection of a subpopulation of cells, and the content of the gate will be highlighted here in the virtual slide. So you know immediately where a certain phenotype is located in the tissue sample. You have a link between phenotype and histology. Extremely popular and prestigious example of this analysis method comes from Harvard University, where they have investigated the immune response against the SARS-CoV-2 virus in thoracic lymph nodes of COVID-19 patients post-mortem back when the pandemic started. So please note, when this was published in August 2020, so just 5 months after WHO had declared the pandemic. They used our Tissuefax platform and our software to analyze 7-color immunofluorescence stained samples. I don't have the time to go into detail, but the paper is published, you can read it. And the main output of this study was that we will have a problem with long-term immunity in corona. We know this today, but when the paper was published in 2020, there were still governments who thought they don't need to do anything against corona, they just wait for herd immunity to come. And this paper was the first, or one of the first indications that this strategy would fail. So by the time this paper was published, this was really breakthrough research powered by Tissuegnostics. The applications also cover the analysis of tumor microenvironment and what we call spatial phenotyping. We see here an example of a multispectral staining colorectal cancer using our tissue spectra with the liquid crystal tunable filter. After unmixing, you get very clear and spectrally distinct staining pattern of this immune checkpoint staining. And then we do the single cell analysis. We have the link between the scatter plot and the histological sample. We know where the different cell types are. As you can see here, subpopulations of cells are identified and visualized with different colors. We can create distance zones around the epithelium, the tumor, or whatever reference structure you're interested in, and then count how many cells of which subtype are where in the tissue, which is visible here in case of CD4 positive cells. But we can also do neighborhood, others call it spatial biology, visualized here by these lines. You can define any cellular subtype as reference and ask the question, which other subtypes of cells or specific other cells like tumor cells are in the vicinity of your reference phenotype. This is what we call neighborhood analysis, or is in general referred to as spatial biology. The data can be shown in form of histograms, scattergram, 3D scattergrams, violin plots, or by manifold learning. That means by you put all your measurement data into a machine learning or deep learning based algorithm like T-SNE, and the algorithm will show you cluster analysis, and using the backward connection you can visualize where in the sample are certain subpopulations of cells that the T-SNE plot shows you. But we also support other types of manifold learning like UMAP or SONG. SONG is a new technology from the University of Melbourne and stands for self-organizing nebulous growth. Tissuegnostics offers the development of tailored analysis pipeline to support our clients to meet their research needs. And this is a commercial service. We develop apps which can be then integrated, seamlessly integrated into the main user interface of StrataQuest, but they come with their own parameter control window, their own graphical user interface within StrataQuest. And there are practically no limitations to what we can analyze. Please visit our website, the App Center. This contains currently more than 70 applications, and within this year it will reach to 100. And we also offer custom app development for the same price as off-the-shelf apps. To summarize, TissueFax cytometry or tissue image cytometry. Tissue image cytometry is the name of the technology. TissueFax is the name of the product. Will help researchers to move from image to data and thereby increase the observer independence. I would like to acknowledge our academic collaborators around the world and conclude my presentation with the link to our partners in Chile. We are working with our dear business partner Ursulab. You can contact Juan Carlos Torres, but also Vanessa Deda from Tissuegnostics Latam division, or myself anytime. Thank you very much for your attention.